Hello, my name is Michael with the RouteHub training program, and I'm going to show you how to deploy the Palo Alto Network Security Appliance step by step for many of the practical cases that you will deploy for your own environment. The first step for deploying any network is building the design and the network diagram. This will show how everything is connected, including all of the IP addresses that are needed. This here reflects the network diagram and our design that will be focused on this video series. So this design we have completed for many of our customers that are using the Palo Alto Networks firewall, or the PAN firewalls in short. We will have changes to this design when we configure different features and protocols, but overall this would be the general design that we'll be configuring. But let's quickly discuss our design and what will be used in this video series. A larger version of this picture is available in your package for reference. The overall topology consists of two locations. We will have our main location using a PAN firewall connecting into a two-tier LAN topology, where we will have a core and an access layer. The PAN and our server farm will connect directly into the core, including the access layer. Our core switch will be the Cisco Catalyst 3750 series, which is a layer 3 switch. The access switch will connect all of our endpoints, which will be our corporate users and our guest users. Our access switch will be a simple Cisco Catalyst Layer 2 switch. Also connected off the PAN will be our management network, which will have an Active Directory server, which will provide LDAP services. It will also have an NMS and a NetFlow server, which we will use later on in our deployment. Our computer, where we will administer the PAN, will also be connected into this management network. The PAN security appliance that we'll be using is the PAN 200. And this here is the stencil for what that unit looks like. It has 4 Ethernet ports, 1 management port, and a console port. So in our design, Ethernet port 1/1 will connect into our internet connection. Ethernet port 1/2 will connect into our LAN as a layer 3 interface. And Ethernet 1/3 will also connect into our LAN, but configured as a layer 3 sub interface, supporting 802.1q, where we will extend VLANs across this connection. This will provide another way how you could configure interfaces on the PAN appliance. You will also see the management interface, and using this is strongly recommended for all administration and PAN management functions. The reason for this is that it uses a different plane, the management plane, where we can keep all of our server and user traffic on the data plane for better resource separation in terms of CPU resources. Our design also includes a remote site that is using a Cisco IOS router, the Cisco 2801 series router to be exact. And this is here because we will configure a site-to-site IPsec tunnel between our PAN and this Cisco router. Next, let's talk about the IP addressing and subnets that will be used in our design. So our main location will be configured for 7 networks. We will have our WAN subnet, which will be a public IP block that we have obtained from our internet provider. We will have an interconnection subnet that will exist between our PAN and our Cisco core switch, configured as a layer 3 connection. We will have our server network, which will be 172.17.201.0, and we will have a user subnet, which will be 172.17.101.0. These two networks will be routed directly within our LAN, and this will make up our trusted network, or the LAN zone. However, if any of these networks want to access the internet, which we call the untrusted network, or the WAN zone, then they must travel through the PAN appliance where security policies are enforced for protection. Our management network will use subnet 10.67.78.0. This is our local lab network. Another subnet will be for our guests, using subnet 172.17.11.0. Now this will not be routed on our core, but on our PAN appliance. This will be the default gateway for our guest users. And this means that if our guests want to access the server or the user network, they must be routed through the firewall. And from there, we could apply a policy specifying what the guests can access on our trusted LAN. But we'll also have a subnet for our client VPN users, which will be 172.17.254.0. Now, for many of these networks that we mentioned here, they will be configured as VLANs, which you will see in the design. So VLAN 101 will be our user network, VLAN 11 will be our guest network, and VLAN 201 will be our server farm network. If you are extending multiple VLANs across a single interface, then the protocol 802.1q trunking must be configured, and that information is also reflected in our diagram. The last network in our design is for the remote site, and that's using a single LAN subnet of 172.18.101.0. But these represent all the networks that we'll be using in our design. So once again, this is the diagram that will reflect all the ports and IP addresses that we'll be using during our step-by-step deployment.